Right, I've got to solve these, and this again is not standard, it's all a bit mixed up. And you could rearrange it to get to the D's and the C's onto the left hand side, all as numbers onto the others, but personally I'll do it by substitution. And by doing that, here I can find out very easily from here what D equals. So that would come across here, take away 1 from both sides, we'll say that D equals 4C's minus 1. And that's the key thing, because then that, instead of writing D here, I could write 4C minus 1. So that 4C minus 1 is there. So I'm going to technically I'm going to sub D equals 4C minus 1, substitute D equals 4C minus 1 into, I call that equation 2. And that will give me 4C plus 4C minus 1. That's the D. Then I have to add the 5C, and that equals 11. And that will say, if I want to add them together, I get 9C equals 12 divided by 9. C equals 12 over 9, which equals 1 1/3. That's not good enough. I need to find out what D is. Well, I know that D equals 4C, do that. So I'm to sub C equals, I'm going to put it as 4/3 because it's easier, into we'll call it here equation 3, and that will say that D equals 4 lots of that will give me 16 over 3, take away 1, which is, that is 5 1/3, take away 1 is 4 1/3. I now need to see if it's true, because these look a bit weird numbers. So let's try it. Let's do into equation 2, because I've used the first one, or bit like that. So I'm going to get D, which is 4 1/3, plus 5 lots of this, and that is, we decided was 4/3. 5 lots of that will be 20 thirds, and that equals 4 1/3, plus 20 over 3 will be 6 2/3, and that'll be 4 and 6 is 10, plus another 1, 2/3 and a 1/3 is 1, so 10 plus 1 is 11. It does equal that. So even my weird numbers of 4 or 1 1/3 or 4/3 and 4 1/3 came up right. But substitution, so powerful. And if you're doing quadratic ones, as you'll find out, you have to do them by substitution. And that's tougher ones done.